Hi students, today we will discuss moving charges in magnetic field. So first of all, can you tell me if a charge is at rest, what it will do now? It will create electric field, right? So it will generate, it will do electric field, right? Suppose if a charge is moving, it will generate magnetic field. Suppose if a charge is accelerating, it will create electromagnetic wave, right? So today's topic, so we'll study only this one now. This topic will be studying in electrostatics now. So this one, if a charge is moving, it will generate a magnetic field. And if it is generating magnetic field, okay, a moving charge is generating a magnetic field. And what we will do now, we will make that charge to enter into the magnetic field. When a charge is entering into the magnetic field, what will happen now? See, already magnetic field, external magnetic field is there. If a charge is entering into the magnetic field, so definitely it is going to experience a force, right? So, but if a charge is at rest in the magnetic field, will not experience any force, right? Why? Because there is no magnetic field here. Only moving charges will experience a force in the external magnetic field. What is that force now? Suppose here there is a one magnet. Okay, what is that force now? Force F is equals to, so Q into, therefore V cross B. So therefore you can write it as in the vector form now. F is equals to Q into V cross B. If you cross product, if you remove it now, Q into V into B into sin theta. Theta is nothing but a angle between velocity and magnetic field. You know that we already know cross product means what? So cross product, so you know how to do the cross product, no? And the direction of the force. So the direction of the force is always perpendicular to the V and B. We already studied so many times, no? If it is A vector is there and therefore there is a B vector is there. If you are doing cross product of this one now, you will get it as C. So definitely it is perpendicular to both A and B. So you know that force, it will be perpendicular to the velocity and force will be the perpendicular to the magnetic field. Even we can write down here. So perpendicularity condition, you know that dot product will be 0. So F dot V, so it will be equal to 0. F dot B, it will be equal to 0. This condition also we can write it. Let us discuss still more detailedly about this force now, right? So F is equals to Q into V cross B, or we can write down Q into V into B sin theta. Correct? So force depends upon the charge and depends upon the velocity and depends upon the amount of magnetic field and also depends upon the angle. So if theta is equals to, okay, so when will be the force will be maximum or when will be the force will be 0? So force is maximum. So when it will be the force will be the maximum, no? So force is maximum force it will be there, no? That is nothing but a Q into V into B, that is nothing but a sin theta is equals to 1. Sin theta is equals to 1 means what? Theta is equals to 90 degree. That means if a charge is entering perpendicular to the magnetic field, so then it will be experiencing a maximum amount of force. And another one more, when the force it will be 0. So if a charge is 0, also force is 0. That means if you are sending a neutron does not have any charge, no? So it will not experience any force. If a non-charged particle, no, entering into the magnetic field will not experience any force. Also, if a charged particle is not moving, so also will not experience any force. Already why? Because already I told, if a charge is moving, generate the magnetic field. and if there is no other external magnetic field is there, so also force will be 0. Also if it is sin theta is equals to 0, that means implies theta is equals to 0 or 180. Means what? If a particle, if a charged particle is entering in the direction of your magnetic field or opposite to the direction of your magnetic field, so it will never experience any force onto this, right? So force will be 0 in all these cases now, right? So be careful, we can so many times some questions can be asked now like this. So this is suppose magnetic field, so here magnetic field is B here now, so B, suppose there is a one charge is there now, this one charge is there now. So what we are doing now, we are continuously increasing the magnetic field. Suppose if you are continuously increasing the magnetic field, what will be the force acting on the charged particle? So because here charge is at rest now, so definitely even you are changing, whatever you are changing does not experience any force, no, force will be force acting on the charged particle will be 0 only. So be careful, these are the conditions now. And one more important, you need to understand direction of the force. I already told, so direction of the force, therefore it will be perpendicular to the velocity and perpendicular to the magnetic field. So you can calculate, so the direction, so many methods are there, no? Best we can go for Fleming's left hand rule. So what is this Fleming's left hand rule now? You have to take your left hand, right? So stretch these three fingers now. So 3 fingers, right? So these 3 fingers are mutually perpendicular to each other. So this, right, central finger, it is indicate that central finger indicate that C is a nothing but a current. Current is nothing but a flow of positive charges. That means if a positive charge is moving in one direction, so that direction you should take it as central finger. So first finger you have to take, this is your direction now. First finger F, it is going to right, this will be tells that it is a field, and thumb indicate that motion, so therefore it is going to experience a force. So this is direction of positive charge, this is a field, this is your force. So Fleming's left hand rule we always follow to determine the direction now. Clear? Now let us see one application here now. Suppose there is a one magnetic field is there. Okay, magnetic field, here I am writing like this, therefore it is into mark, is indicate that so the field is into the board, right? This into mark indicate that it's nothing but it is into the board. Clear? So the field is into the board. This is what a magnetic field, right? Magnetic field is coming like this. You are understanding? So here suppose there is a one charged particle is entering here now, right? So charged particle which is entering here now, positive charged particle now, so it is entering with some velocity, right, perpendicular. What is the direction of your magnetic field? It is inside. So what is the direction of your positive charge? This side. In which direction of force will experience now? Use Fleming's left hand rule. So positive charge, so this is your direction, so this is your field, therefore it is like this, it is going to experience a upward force, therefore it is going to experience a upward force. Perpendicular is there now, 90 degree. So what will happen now? So everywhere, see, as soon as it is entering now, therefore it is going to continuously going to experience a force now. So therefore it is going to turn like this, it is going to turn like this, it's going to turn like this, right? So therefore even if the particle is at this point, so this is your direction of your positive charge, so this is your field, this side it will be your force, so it is going to experience a force toward this side. Clear? So similarly continuously it is going to act onto this one, no? So therefore here it will be therefore it is going to experience this is a velocity, so this is your velocity, so this side it is your field, this side it will be our direction, no? So therefore it is going to experience a downward force, therefore it is comes out, so with this one, no, right. Now what will be the radius of this one? What is the radius of this one now? We can calculate the radius of curvature of this one, no? So radius, right. So here circular path is there, means centrifugal and centripetal force, no? What is the centripetal force? So mv square by r, right. So other force is what? This force. So this force is nothing but a q into v into b, q into v into b. So sin theta is equals 90 because charged particle is entering into the, right. So perpendicular to the field, sin 90 is 1. So therefore here one velocity gone here, no. So we can calculate radius is equals to mv by qb, right. mv is nothing but a mass and velocity. So mass into velocity of a charged particle means is nothing but a momentum by qb, clear. So if it is having kinetic energy of this particle, no, suppose kinetic energy, so what you can write, kinetic energy, so momentum and kinetic energy you can write it as square root of, so 2m into kinetic energy, right, by qb, you know it now. Therefore kinetic energy, what is the formula here, no. So kinetic energy is equals to half mv square, this is your kinetic energy. So here multiply with m, therefore it is nothing but a p square by 2m, this is nothing but a kinetic energy. P is equals to 2m into kinetic energy, you can write it. So this charged particle is gaining kinetic energy, so because we are applying the potential difference. Suppose if you are accelerating this charged particle by applying certain amount of potential difference here, negative and positive. So if you are applying the potential difference is nothing but it's like a v, so it is gaining kinetic energy. So what you can write it now, so radius it will be equal to square root of 2m, kinetic energy is nothing but a charge into potential difference, this is the potential difference, by qb. So these are the formulas for radius of the charged particle, right. So you can calculate the kinetic energy from this one now, so many things, right. So next one, so we calculated the radius, right. Now we can calculate the angular velocity, time period and frequency, right. So here instead of this one, okay, we'll write it now. So here we can write it as at this point, therefore here this force we can rewrite it as, therefore m r omega square it will be equal to, so therefore here q into v into b. So r we want to remove it, no, therefore you can write down m into mv by, so qb into omega square qvb. So what I can write it now here, so this velocity and velocity get cancelled, so this omega square, what you can write it here, omega square is equals to, so qb into qb, therefore qb whole square by m square, therefore m this is whole square, therefore omega is equals to qb by m. So this it will be your angular velocity. Omega you know it, no, omega is nothing but a 2 pi into f, or omega is nothing but a 2 pi by t. You can write down the frequency, what is the formula here, no, so 2 pi into f, therefore qb by 2 pi m. So this it will be your frequency. A time period reciprocal of this one, no, that is 2 pi m by it is qb. So observe here one point very carefully, you can observe, no, angular velocity, frequency and time period, these all are independent of the velocity. So there is no velocity term in this one now, therefore with what velocity you are projecting, no, so therefore it is not going to change angular velocity, frequency and time period, no, right. And one more important point, see here. So here the force is acting perpendicularly, right, this is nothing but like a centripetal force, no. This you remember that centripetal force will never do any work. So what is the work done by this force, no? So work done by this force, it will be equal to 0. Why? So because it is perpendicular and is f dot v is nothing but a power is 0, work done is 0. So therefore the magnetic force will never do any work on the charged particle. If it is not doing the work, therefore the speed of the particle will not change. That means speed of the particle here, everywhere the speed of the particle will be same only. Why? Because it is not doing any work. Clear? Right? So we'll do some questions related to this one. No? So observe this one more time. Okay. So we'll write down one more time the formula. So therefore r is equals to radius of this one, no, mv by qb, or momentum by qb, or square root of 2m into kinetic energy by qb, right. So therefore square root of 2m into q into potential difference by qb. So these all are the formulas for radius. Angular velocity we already written, no? Angular velocity is nothing but a qb by m. So frequency is equals to, so qb by 2 pi m, time period is equals to 2 pi m by qb. Correct? So these all are the formulas we derived now. We'll do one question, right? So observe this. So we'll do one simple question here, no? So let us see. We can cover all the questions in this one, no? Let us see here, no? Suppose one charge is there, no? One particle is there. What are the particles? No, you can take two particles. One is proton and one is alpha. So we'll take one proton and alpha. So now this proton, first of all you should know basics of the proton, basic of alpha. Proton is having mass m, so it is having charge, positive charge, no? Therefore charge of this one is nothing but a plus e. So alpha particle is what? Therefore it is a helium nucleus. Helium nucleus means what? Helium is having two protons and two neutrons. So mass it will be equal to, therefore 4m, and helium nucleus, two electrons are removed. So the charge of this one is nothing but a plus 2e. This is the charge of alpha, charge of proton, right? So remember this, these two particles are there. So what we are doing now, we are sending these particles into the magnetic field, into the same magnetic field with, right? So magnetic field is constant. How we are sending now? Suppose, right? First one, with the same velocity. Same velocity. What we have to do? We have to calculate. So radius of the proton by radius of the alpha, right? So radius of the proton by radius of the alpha. So same velocity is there, no? So velocity is constant, magnetic field is constant. So therefore, what you can write it now? Radius, it will be equal to, so when it is same velocity is there, radius is directly proportional to the m by it is q. Clear? So directly proportional to mass, inversely proportional to the charge. So you can write down, therefore directly proportional to the mass, therefore mass of the proton by mass of the alpha into inversely proportional, so charge of the alpha by charge of the proton, right? So mass of the proton is nothing but it is m by therefore 4m into, so charge of the alpha is nothing but 2e by e, gets cancelled out, therefore it will be, so 1 by 2 radius of the proton by radius of the alpha. Clear? If they are projected with the same speed, like that we can have so many questions, no? If they are projected with a, right, same continuation question, no? So proton and alpha, if they are projected with the same momentum, okay. Here also we can add one more question here, no? So therefore they are asking the radius, no? So now okay, we can calculate similarly angular velocity, frequency and time period, no? So therefore it does not show effect of the velocity. So angular velocity you can write it now, right? So here with the same momentum is same. So radius it will be equal to, what is the formula here now? Radius r is equals to, so therefore momentum by qb. Same momentum, same magnetic field. So radius is inversely proportional to the charge. So what you can write it now? Radius of the proton by radius of the alpha. So radius of the proton means inversely proportional, charge of the alpha by charge of the proton. So charge of the alpha is nothing but a 2e by e. So this will get cancelled. Therefore it is 2. So it will be the ratio is will be 2. Clear? So now if they are projected with a same kinetic energy, kinetic energy, what is the formula here now? R is equals to square root of 2m into kinetic energy by therefore qb. Correct? Same kinetic energy same, B is also same. So therefore how the radius it will be there? Radius is directly proportional to root m by it is q. Clear? So now radius of the proton by radius of the alpha, it will be equal to root of mass of the proton, directly proportional, inversely proportional to the q, out of root. Therefore q alpha by q proton, right? So mass of the proton is how much now? it is m, mass of the alpha is nothing but a 4m into, so 2e by e, you will get cancel, therefore it is 1 by 2, 2, therefore 1 is to 1 if they are projected with the same kinetic energy. Same question you can do it, no, if they are projected with a same potential, if they are accelerated with the same potential difference. Now if they are accelerated with the same potential difference, what is the formula here now? R is equals to square root of 2m into q into potential difference by qb. What do we know it now? It will be directly proportional to q. V is constant, b is constant, no, so directly proportional, no, therefore R is proportional to root m, this is root q, this is q, means totally root m by q. Clear? So therefore here we can write down radius of the proton by radius of the alpha, it is nothing but a directly proportional mass of the proton by mass of the alpha into, so charge of the alpha by charge of the proton. Why? Because inversely proportional, right? So now mass of the proton is m, mass of the alpha is nothing but a 4m into 2e by e, you will get cancel, so therefore 1 by root 2, this is a ratio. Clear? So in all the situations, no, you can calculate what will be the time period, what will be the angular velocity. So now sometimes one question they can ask, you know, so if they are like some question is there, no, they are asking what will be the curvature. If they are asking the curvature, so therefore what you have to do? Curvature means what? See, if it is like this is there, so therefore if it is like this is there, so what does it mean now? This is having more curvature, this is having less curvature. So less curvature means radius is more, more curvature, more curved is there, radius is less. So radius and curvature are inversely proportional now. Radius is inversely proportional to the curvature. If they are asking curvature, please don't confuse, don't calculate the radius, it is inversely proportional to the radius. If they are asking what will be the curvature of the proton by, so curvature of their alpha, so therefore it is inversely proportional, no, you will get it as root 2. So please don't calculate the radius, curvature and radius are inversely proportional. Clear? Right students, we will do one question here now, right. So suppose here there will be one magnetic field region is there now, this is one magnetic field region, this type of questions frequently asked in JEE mains. So this is D region is there now, distance, okay, this the region of the magnetic field is very lesser compared to the radius. So distance is this distance of this one now is less than the radius of the earth now, radius of our particle. Okay. Now if the particle is entering here now with certain speed, what will happen now? Again it is going to experience a force here, so it is going to experience a force, then when it comes to here, so it is going to exit out, therefore it is going to come out, right. So it is going to come out. So with what, okay, this is your initial direction now, so this is your initial direction, with what angle of deviation it will come out? We want to calculate this at what angle it is get deviated now. So this is coming out, it is tangentially, so we can draw it now, therefore this is should be our radius of this one now, right. So this it should be your distance of this one now, and this is theta, so definitely this is 90 degree, this is 90 minus theta 90, this also theta. So this is radius now, so we want to calculate the theta only, so theta, so therefore sin theta, right. So sin theta, so is equals to sin means opposite side by hypotenuse, no, so d by r. We know r is nothing but a mv by therefore qb, so we can write it as sin theta is equals to d by mv by qb, q into b, r theta is equals to sin inverse of d into q into b by mv. So this is your theta now, right? Now one more concept now we will discuss here, that is helical path. Helical path. Suppose there is a one magnetic field is there in the horizontal in the some region here, no, suppose horizontal region here, no, listen. So here there is a particle which is entering here, no, q is entering with some speed, no. So with making certain angle theta here. So it is v making an angle theta here now. Therefore what is going to happen now, this speed what we will do, we will split this one, no. So this speed, okay, v therefore v cos theta, it will be in the along the direction, no. So v sin theta which is perpendicular to the magnetic field. This is a magnetic field, right? So this is a magnetic field. Now so here you see v sin theta is there, no, v sin theta which is perpendicular to the magnetic field, v cos theta is along the magnetic field now. So when it is along the magnetic field, I told you if a particle is entering or moving along the direction of your magnetic field, it is going to experience a force is 0. So there is no force on this one now. Which one will experience a force now? V sin theta will experience a force. How? It will make the circle onto this. Therefore this due to this v sin theta, it will make the circle now. So but this speed is there, no? V cos theta is there, no, it is not making you to rotate in one place. So after completing of this, no, meanwhile, so this is pushing towards this side, so therefore it will be able to make it as like a helical path like this. But if you are viewing from here, it will looks like a circle, but if you are viewing from here, no, therefore it will be able to move in the forward direction now. You understand? So if a particle is entering into the magnetic field by making an angle theta, it will undergo in the form of a helical path, right? So what should be the radius of this one now? So radius is because of due to this velocity, radius it will be equal to m into v, right? So sin theta by qb. This is the radius of this helical path onto this one. What will be the time period now? Time period it will be equal to 2 pi m by qb, right? So because it does not depend upon the speed of this one, right? Now we want to calculate how much amount of pitch of the helix. Pitch of the helix means what? The distance between the two consecutive turns of this, or two consecutive threads. This we can call it as like a pitch of the helix. Pitch of helix. How to determine now this much distance, that is one circular path to another circular path, this distance is because of due to this v cos theta, right? So therefore v cos theta, so how much time taken now to complete of this, now this is nothing but a time period into time period. Therefore what you can write it now, therefore 2 pi m into v cos theta divided by therefore qb. So this it will be your pitch of the helix. Sir, here you are telling it is v means no, pitch of the helix is nothing but a distance. So t is nothing but a time period. Understand? No? So like this you can calculate the pitch and radius and time period for the helix now, right? So okay students, right? So some questions, numerical questions, no, we'll do in the next video. So thank you for watching. Please subscribe to my channel. I hope you learned these moving charges in the magnetic field properly. Okay, thank you.